Hi all, welcome to our question paper based discussion session. So today we are going to question number 34. Those who haven't watched the previous videos regarding question number 30 to 33, kindly go back and watch the videos and come here. Question number 34 is usually asked from electricity chapter and it's an OR question. So a question based on resistors, current, all that may come for this question. So now let's go to the first question. Let's read the question. Write in the form of a formula a relationship between the resistance and resistivity of an ohmic conductor. So first of all, they are asking us to write the relationship between resistance and resistivity. We know the relationship is R is equal to rho L by A. This is the relation. R stands for resistance, rho stands for resistivity, L stands for the length of the conductor, A stands for area of cross section of the conductor. Just write down that. Then next part is a wire of length L and resistance R is stretched so that its length is doubled. So in this case L is doubled, L becomes 2L, and area of cross section is halved. So area of cross section became half. A became A by 2. So A became A by 2. L became 2L. Now they are asking, how will its resistance change? And second question is, how will its resistivity change? Let's see the first question, A part. Let's consider this as the normal resistance. Let me call it as R itself. Now for the second resistance, let me call it as R dash or R2, whatever you like. So R dash is equal to rho. Resistivity is not changing. So resistivity is rho itself. L became 2L. So instead of L, I should write 2L divided by area became A by 2. Area is A by 2. So now I'll write numerator as it is, rho into 2 into L. So it's a fraction, rho 2L by 1. Now this fraction, when I take it here, the division becomes multiplication and we'll write the reciprocal of it. That's the usual mathematical rule. So I'll write 2 by A. Okay. So now it can be written as 2 into 2, 4. 4 times rho L divided by A into 1 is A. So 4 times rho L by A. We already know that rho L by A, that is our R. So I'll just rewrite it once again. This R dash is equal to 4 times rho L by A is same as R. So I can write R dash is equal to 4 times R. So as per this question, how will the resistance change? Our new resistance will be 4 times the first resistance. That's the answer. Now, second part is, B part is, how will the resistivity change? Which means how will rho change? Actually, resistivity is the characteristic property of a material. So here the material is not changing. If you are taking copper, then it's copper itself. Even though its length or area, those factors are changing, but still the material is not changing. Since the material is not changing, resistivity will not change. So resistivity will be a constant since the material is not changing. It's the characteristic property of a material. So since the material is not changing, resistivity will not change. Okay. So resistance will change. R dash is equal to 4 times R, but resistivity will not change. That's it. We'll go to the next question. A piece of wire having resistance R is cut into 4 equal parts. So as I told you, this question is an OR question. So this is the OR question of the question that we have seen now. So here a long wire was there. Its resistance was R. Now this is cut into 4 equal parts. 1, 2, 3, 4. 4 equal parts. Okay. Here the idea is, if this was having a length L, now length of each part will be L by 4, L by 4, L by 4 and L by 4. If you add all this L by 4, we'll get L. Okay. So L was the initial length. Now the length of each part is L by 4. Now we'll go to the question. How does the resistance of each part compared with the original resistance? We know original resistance is R. It's already given to us. Original resistance is R. So now let's find out the new resistance. Okay. So let me call the new resistance as R dash. We'll find out what is R dash. So we know R is equal to rho L by A. Now the resistance of new part, that is this one, let me call it as R dash. To find out R dash, let's see what difference came there. Rho, resistivity is not changing. Length, instead of L, now we have L by 4. So L became L by 4 divided by area is not changing. So area is A itself. Now in the next step, R dash is equal to rho L by 4 into A is same as A by 1. So it becomes 1 by A. So now I can rearrange it and write it like R dash is equal to, let me take all the numericals outside. Let me write it first. That is 1 by 4 of rho L by A. For us, this rho L by A is same as our initial resistance. R is equal to rho L by A. We already have it here. We have written that here. So instead of this, I'll write R. So R dash, the new resistance, the resistance of each part is equal to 1 by 4 times rho L by A, which is same as R. Okay, so our new resistance is 1 by 4 times the first resistance, or I can write it like R dash is equal to R by 4. This is the first answer. So they are asking us, how does the resistance of each part compare with the original resistance? So compared to original resistance, each new resistance is equal to 1 by 4 times the first resistance. This is the answer. Okay, now let's see the second part. The second part of the question is, if 4 parts are in parallel, how will the resistance of combination compared with the resistance of original wire? So resistance of original wire is already here, that's R. So we have to connect all these 4 parts parallelly. So I should connect first one, second one, third one, fourth one. All those 4 should be connected parallelly to a cell. Then I should find out the resistance of this. So now let me consider each part like a small resistor. Each one having the resistance that we got here, that is R by 4. So this one's resistance is R by 4. Again, this one here is R by 4. Again, R by 4. Again, R by 4. So 4 R by 4 resistors are connected in parallel. We know the equation for parallel connection. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Here we have 4 resistors, so we'll write this much. So again, 1 by Rp is equal to 1 by R1. So reciprocal of the first resistance, that is R by 4, becomes 4 by R plus second resistance, reciprocal of second resistance, 1 by R2. So R2 is also R by 4, so I should write 4 by R again. Third one, again 4 by R. Fourth one, again 4 by R. So I am adding all the 4 resistors here. Now 1 by Rp is equal to, denominator is same, so I can write R. 4 plus 4 plus 4 plus 4. I have 16, so 16 by R. So now taking reciprocal here, Rp is equal to R by 16. This is the answer, which means now our resistors, when they are connected in parallel, it is same as 1 by 16 times of first resistance. So in the first question, our new resistance of each part was equal to 1 by 4 times the initial resistance. Now in the second case, when these 4 resistors are connected parallelly, then their effective resistance, the parallel effective resistance, is same as R by 16. We'll go to the next question. See this question. A potential difference of 220 volt is applied across the resistance of 440 ohm in an electric iron. First question is find the current. Second one is heat energy produced in 30 seconds. So first of all let's write the given values. A potential difference of 220 volt. So the potential difference V is given as 220 volt is applied across a resistance of 440 ohm. So resistance R is given as 440 ohm. In an electric iron, find the current. So first of all, we should find out current. Okay, let's do that first. We know as per Ohm's law, V is equal to IR. Okay, so I can rearrange and write it like I is equal to V by R or R is equal to V by I. So anyway, using Ohm's law, let me substitute this equation. So V is equal to I into R. I'll substitute the values. V is 220 is equal to I is not given, R is 440. I'll keep this I here equal to as it is 220 as it is, 440 will come here. So 440, 0 cancelled. Now I is equal to 22 divided by 44. If we see with 11, 11 into 2 is 22, 11 into 4 is 44, 2 by 4 that is same as 1 by 2 which is equal to 0.5 ampere. So the current is 0.5 ampere. Now we have to find out the heat energy produced in 30 seconds. We know the equation for heat, H is equal to I square RT. So we can use any equations as we wish. Here I is also available, R is also available, and the time is also given, that is 30 seconds. It's an SI unit. So we'll use this equation directly. H is equal to I square. I is 0.5 whole square into resistance. Resistance is 440 into time given is 30 seconds. 30 seconds. You have to multiply everything. H is equal to 5 5s are 25. It will be 0.25 into 440 into 30. So here it is actually 0.25 is 1 by 4. So 440 by 4 into 30. So 4 11 times. So it is 110 into 30. So H is equal to 3 into 11, that is 3300. SI unit of heat is joule. So 3300 is the answer. So here please remember the Ohm's law, V is equal to I into R. So we have some shortcut to remember this one. When we have V, write V here, I here, R here. V is equal to I into R. When they come in the same line, just multiply. Now V is equal to I into R. I is equal to V divided by R. When we have a line here, just divide. R is equal to V divided by I. Remember this one. Now again coming to Joule's law, we have H is equal to I square RT. Here we were able to use this equation because resistance, time, current, everything was available. Suppose if it's not available, we have other equations as well. H is equal to, instead of I, substitute I is equal to V by R. Then we'll have V square by R square into R into T. So here 1R and R will get cancelled. Remaining is V square by R into T. This is another equation to find out heat. Or else H is equal to, same equation, I square RT. Here substitute for R. R is equal to V by I. So we have I square into, instead of R write V by I into T. I and I got cancelled. So here we'll have the equation V into I into T. V into I into T. This is another equation for heat. So we may use either this equation or this one or this one. So based on the situation, we should pick the equation and do it. See, V into I is same as power also. So we can say it like heat is equal to power into time. Here also V square by R is also power into time. Here also I square R is also power, so power into time. So these are the equations for power also. I square R, V square by R, V into I. These are the equations for power as well. So if power is asked, we may use these equations to find out. Just remember all this. We need not by heart all these equations. Just remember the first equation. Here, remember Ohm's law, V is equal to IR. Here, remember the Joule's law, H is equal to I square RT. Then, based on the substitution, you will be able to get the answers, get the equations. Then, based on the situation, based on whatever is available, substitute the correct equation and get the answer. Now, we'll go to the next question. Calculate the cost of seeing 2 movies on color TV. So, 2 movies on color TV daily for the month of September. So, September, how many days are there in September? January, February, March, April, May, June, July, August, September, 30 days. So, September has 30 days. Now, given wattage of color TV is 60 watt and the duration each movie is 2 hours 30 minutes. And for 1 kilowatt hour, the cost is rupees 4. We know 1 kilowatt hour is same as 1 unit. Usually we will use unit, 1 unit. 1 unit is same as 1 kilowatt hour. Now here they have directly given us 1 kilowatt hour. Sometimes in the question it will be given like the cost of 1 unit. It is rupees 4. Okay, let's find out. See, actually 1 unit is same as energy. So here we should find out the total energy. Total energy is nothing but energy, it is the heat energy here. Energy is equal to power into time. We will be using this formula, this equation. We will be finding out energy using this equation, power into time. Let's find it out. First of all, calculate the cost of seeing 2 movies on color TV daily. Let's find out the units used per day and afterwards let's multiply it with 30 days and then multiply it with the cost, that is rupees 4. Then we'll be able to get the total amount. So first of all, let's start. 2 movies. So 1 movie's time is, for 1 movie, the duration is 2 hours 30 minutes, which means 2.5 hours. Okay. So for 2 movies, the duration is 2.5 plus 2.5, that is 5 hours. So this will be the time that we are taking for 2 movies. Now, the power of TV is given as 60 watt. 60 watt is the power. So the time that we will take is 5 hours and the power is 60 watt. Okay. So this is for 1 day. So in 1 day we are watching 2 movies. So we are using the TV for 5 hours and the power of the TV is 60 watt. So now let's find out the energy. Energy is equal to power into time. So here power is 60, time is 5, 6 are 30, so 300. Power was given in watt and the time is hour. So it is watt hour, 300 watt hour. Now let's calculate for 30 days. This is only for 1 day. Now we have to calculate for 30 days. So we got the energy for 1 day. So for 30 days, just multiply this energy into 30. So that is 300 into 30 watt hour. So 300 into 30, 3 3s are 9, 0, 0, 0 watt hour. See, in the question, it's given as 1 kilowatt hour. 1 kilowatt hour is same as 1 unit. So now we'll convert from watt hour to kilowatt hour. It's nothing, just divide by 1000. So that is equal to 9000 divided by 1000 kilowatt hour. So all the zeros got cancelled and we got 9 kilowatt hour. So this is the total energy consumed for 30 days. Now we have to calculate the cost. So for 1 kilowatt hour, the cost is rupees 4. So for 9 kilowatt hour, the cost will be equal to 9 into 4. That is rupees 36. So here, when we watch 2 movies per day on a TV, which is having a power of 60 watt, for 30 days, that is in the month of September completely, then the amount that we have to pay will be rupees 36. So whenever we get questions like this, remember we'll be using the equation energy is equal to power into time. So find out the power, multiply it with the time. Maybe it will be given for 30 days or the name of the month will be given. So just find out the number of days in the month and just multiply. Remember one thing, usually it will be given us the price for 1 unit or for 1 kilowatt hour. So maybe our answer will be in watt hour. We have to convert that to kilowatt and then find out the answer. Only then the answer will be correct, or else it will be wrong. So please keep this in your mind. We'll go to the next question. An electric heater rated 1100 watt operates at 220 volt. Calculate its resistance and the current drawn. So first they have given the power. Power is equal to 1100 watt, and the potential difference is given as 220 volt. We have to calculate the resistance and we have to calculate the current. Here we'll be confused, thinking that power is given and voltage is given, potential difference is given, and we are asked to find out the resistance. We are asked to find out the current. We know Ohms, according to Ohm's law, V is equal to IR. If I and R is given, we'll be able to find out V. If V is given and I is given, we'll be able to find out R. But here it's twisted. We have power, voltage. We are asked to find out the resistance and the current. Here we know one more factor, that is power is equal to work done by time, or it is here work done is same as heat energy by time. We know H is equal to I square RT divided by time. So T and T got cancelled. Another equation for power is I square R. As we told in the previous slide, these equations can be used as the equation of power. Just look here. We have the equation I square R, V square by R, and V into I. These can also be the equations for power. So let's see which equation will be suiting here. So as we told earlier, instead of I, if you substitute I is equal to V by R, you will get the next equation. Instead of R, if you write V by I, then you will get the next equation. So we'll have different equations for power. So power is equal to I square R, or we can also write like power is equal to V into I, or power is equal to V square by R. These are all equations for power. Now in this situation, let's see which one can be used. Power is there, potential difference is there, we should find out R. So see an equation connecting P, V and R. P, V and R. So let's take this equation itself. Or if you want to find out current first, you may use this equation as well. So anyone is fine. Let me find out the current first. So P is equal to V into I. Power is 1100 is equal to voltage 220 into I. So I is equal to 1100 divided by 220. 0 got cancelled. So I is equal to 110 divided by 22. If we say with 11 into 10 is 110, 11 into 2 is 22, 10 by 2 is 5. Answer is 5 ampere. So we got current as 5 ampere. Now let's find out the resistance. Now it's easy. You may use any equation to find out the resistance. So even Ohm's law can be used here. V is equal to IR. Here V is 220. I, we don't know. We got I, that is 5 ampere. Now R we have to find out. So R is equal to 220 divided by 5. 5 4s are 20. Again 5 4s are 20. So R is equal to 44 ohm. We got the answer. If needed, we can try with other methods also. So to find out R, if needed, we can use any of these equations. P is equal to I square R. Let me see that. So power is 1100 is equal to I square. The current is 5, so 5 square, that is 25, into resistance. So R is equal to 1100 divided by 25. So 5 5s are 25, 5 2s are 10, again 5 2s are 10, 220 by 5. Again we are getting the same answer. 220 by 5 is equal to 44 ohm. So any method can be used, either this method or this method. Okay, hope it is clear. So please do remember these equations of power so that it will be helpful for you. Just study one equation. If you can't by heart, just remember this is the way in which it came. Using Joule's law, find out the equation for power. Then just interchange. You will get all the equations. Using that, you will be able to find. Now we'll see the OR question. The OR question here is a graph-based question. So whenever we see a graph like this, we can understand that the question is from Ohm's law. Okay, let's read the question. In the experiment to study the dependence of current on the potential difference V across the resistor, a student obtained a graph as shown here. What does the graph depict about the dependence of current on the potential difference? So what does this graph stands for? What does it mean? We know that Ohm's law itself is saying that V directly proportional to I. The graph is also depicting that one. The linear dependence of the potential difference on the current. V directly proportional to I. So if you want, you can write like V directly proportional to I, and you can write one sentence saying that it shows the linear dependence. The linear dependence of the potential difference on the current. That's it. Now we'll go to the second part of it. Here, find the current that flows through the resistor when the potential difference across it is 2.5 volt. So for 2 volt, we have 0.2. 0.2 ampere is the current there. For 2.5, we don't know exactly how much it is. So we can't directly take it from the graph. But we know one factor, that in this setup, anyway, the resistance is not going to change. So using any of the values, if we find out the resistance, then using that resistance, we'll be able to find out the current because the voltage is already given to us. So let's try to find out the resistance here. R is equal to V by I, or we have the general equation V is equal to IR from Ohm's law. So from this we can write like R is equal to V by I. Okay, so let's take any value. Let me take this one, first one itself. When the potential difference is 1, the current is 0.1 ampere. So here potential difference is 1 volt and the current is 0.1 ampere. Let me use these values here. So R is equal to V is 1 divided by current is 0.1. Okay, 1 by 0.1 is R is equal to 10 ohm. Okay, if you just multiply into 10, it will become 10 by 1. So it is 10 ohm. So resistance is 10 ohm. We got 10 ohm here. Now in the question they are telling us that the potential difference is 2.5 volt. From our first case we got the resistance as 10 ohm, which will not change. That's why the graph is a linear graph. So here altogether, wherever you see, the resistance will be 10 ohm. It will not change. So we are using that factor here and we are going to find out I. Again, write Ohm's law. V is equal to I into R. Substitute the values. V is 2.5. I, we don't know. We are going to find out that R is 10. So I is equal to 2.5. 10 will come here. It will be divided. So I is equal to 0.25 ampere. So our current here is 0.25 ampere. This is the answer. So here we are only using one equation, that is Ohm's law. And remember that whenever you get a question like this, Okay, the resistance will remain same. It will not change at all. So using that fact, we are finding out the resistance and we are substituting the value here. Then we'll get the answer. Hope it's clear. We'll go to the next question. This question here is based on the parallel and series connection. So here we should be knowing something. Whenever the resistors are connected in parallel, there the voltage or the potential difference will be same and the current will be different. And if it is series connection, then in series connection the opposite happens. The potential difference will be different and the current will be same. In this question, we have a parallel connection where R1, R2 and R3 are connected parallelly. Now let's go to the question and read it. So in a circuit given below, resistors R1, R2 and R3 have the values 10 ohm, 20 ohm and 30 ohm respectively. So this is 10 ohm, this is 20 ohm and this is 30 ohm, which have been connected to a battery of 12 volt. So this one is having a potential difference of 12 volt. We have to calculate the current across each resistor. We have to find out the current here. Let me call the current as I1 and the current here, that is I2, and the current here, that is I3. We have to find out all the currents I1, I2 and I3. Next is the total circuit resistance. So how much will be the effective resistance? We have to find out the RP. How much will be the effective resistance? Next is the total current in the circuit. So I total, the total current in the circuit also should be found out. So let's see what to do. Here, since it is parallel connection, we know the voltage is same and the current is different. That's why they are asking us to find out the current in each case. So let's use this one. We already know the voltage is same. So voltage is, the potential difference is 12 volt. Now we know the resistance. Let's find out across R1. The resistance R1 is 10 ohm. So now since we have voltage and resistance, we'll be able to find out I1, the current across the first one, using Ohm's law. So in Ohm's law we know V is equal to I into R. So here V is 12 volt is equal to I, we don't know, I'll call it as I1 into R is 10. So I1 is equal to 12 divided by 10. So I1 is equal to 1.2 ampere. I can write like I1 is equal to 1.2 ampere. So I got the first current. Now let's do the same thing for the second resistance. In second resistance again, voltage is same, potential difference is same, that is 12 volt. Now R2 is equal to 20 ohm. We have to find out I2, that is the current across the second resistor. So again Ohm's law, V is equal to I into R. V is 12, current we don't know, I'll call it as I2 and the resistance is 20. So keeping I2 here is equal to 12 divided by 20. So this is same as 6 by 10. I2 is equal to 6 by 10. So I'll get I2 is equal to 0.6 ampere. So I got the second current. Now coming to the third current, same procedure. V is equal to 12 volt. Since it is parallel connection, no change. R3 is equal to 30 ohm. We have to find out I3. Again, V is equal to I into R. V is 12. Current is I3. R is 30. So I3 is equal to 12 by 30. 3 4s are 12. 3 into 10. So I3 is equal to 0.4 ampere. That's it. And there is one more thing. The current that goes from here, that reaches here, will be a value, a particular current. that one after reaching here will split into three parts. Then while coming out again, the same current that went through this part will come out when it is coming out. Okay, so here I1 is 1.2, I2 is 0.6, I3 is 0.4. So the current that reaches here will be the sum of all this, and the current that comes out through here also will be the sum of all this. So here in the C part, so we have done the A part. In the C part, they are asking you the total current in the circuit. So total current can be found out in this way also. So C part, total current I is equal to, or I total is equal to 1.2 plus 0.6 plus 0.4. So 12, 2.2. So 2.2 ampere will be the total current. I total will be 2.2 ampere. You can find out this another way also. Finding out the effective resistance and the total voltage, you will be able to find out the same value. So any step is fine, it's your wish. Now let's find out the total circuit resistance. So here, to find out the effective resistance, we know it's parallel connection. We know the equation 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So now 1 by Rp is equal to 1 by R1, that is 1 by 10 plus 1 by 20 plus 1 by 30. Okay, now let me add the first two. I'll just multiply with 2 here. 10 into 2, 1 into 2. So 1 by Rp is equal to 2 plus 1, 3 by 20 plus 1 by 30. We'll take the LCM. Here 1 by Rp is equal to 3 3s are 9. 90 plus 20 divided by 3 2s are 6. 600. So Rp is equal to 600 divided by 110. 90 plus 20, 110. 0 0 got cancelled. Now 60 by 11. Rp is equal to 5.45 ohm. This is the answer. Let's go to the next question. This is the OR question here. This question is based on the least count. The least count of an instrument. You know what is least count? Least count is the lowest value that you can measure using an instrument. So here the rest position of the needles in a milliammeter and a voltmeter not in use are shown in figure A. So in figure A, we have a milliammeter here and a voltmeter here. They are not in use. Usually when the instruments are not in use, their pointer should be at 0. But in this instrument, it is before 0, 2 steps before 0. And in this instrument, this is 2 steps after 0. So there is a 0 error there. So when we are finding out the answer, we should consider this error and we should do something accordingly so that the error can be cancelled. We should give some correction there. Okay, let's continue. When a student uses these instruments in his experiment, the readings of the needles are in the positions shown in figure B. So this is the reading, figure B. For milliammeter, this is the reading, and for voltmeter, this is the reading. So now determine the correct values of current and voltage the student should use in his calculations. So let's think here. Here already this pointer is 2 steps backward. So when he takes the reading also, this pointer will be automatically 2 steps backward. So we should bring it 2 steps forward. Then our answer will be correct. So it is supposed to be here. Now coming to this one, here the pointer was already 2 steps forward. So when we get the answer also, the pointer will be 2 steps forward. So we should bring it 2 steps backward. It should be here. Only then we'll get the correct answer. Okay. Now before doing all that, let's find out the least count of these. So first of all, let me find out the least count of milliampere. In milliammeter, least count is equal to, let's see what is the gap between two readings. Here we have 0, afterwards we have 10. So the difference between them is 10 minus 0 divided by how many gaps are there? Let's count 1, 2, 3, 4, 5. There are 5 divisions. So 10 minus 0 by 5, that is equal to 10 by 5, that is equal to 2 milliampere. This is the least count. So this is the lowest value that we can measure with this one. So each line, each small line stands for 2 milliampere. Now coming to voltmeter, the least count is equal to, let's see the divisions, it is 0 and 1. So the difference is 1 minus 0 divided by how many divisions or how many gaps are there? 1, 2, 3, 4 and 5. Again 5 gaps. So 1 by 5. So 1 divided by 5 is equal to 0.2. 0.2 volt. So the least count of voltmeter is 0.2 volt. So each small division stands for 0.2 volt. Now let's come to the reading. So here the pointer is supposed to stand here. Already it has crossed 30. So each point stands for 2 milliampere. So already 30 is there, plus on which line is it standing? 1. So here if you look at the line, it is first line, second line, third line, fourth line. It is supposed to stand at fourth line. It's actually standing on the second line, but when we correct it, it is supposed to stand on this fourth line. So 30 plus 4 into the least count value, that is 2. That is 4 into 8. 30 plus 8, that is 38 milliampere is the answer. It's better to write the step, but if you want to cross check, simply using the logic you will be able to find out, each division is 2 milliampere. So after 30, it's 32, 34, 36 and 38. Answer will be 38. You can cross check it like that. Now going to the next one. Here already it has crossed 3. 3 volt is already there. So let me write 3 volt plus. Now on which line is it standing? It's standing on the first line. Actually it's standing on 2, 3, third line, but we should come back 2 steps. So it is standing on the first line. So 1 into the least count there is 0.2. 1 into 0.2 is 0.2 itself. 3 plus 0.2 is 3.2 volt. So the voltmeter reading is 3.2 volt. As we did earlier, each small division stands for 0.2. So after 3, it's 3.2, which we have taken. After that it is 3.4, then 3.6, 3.8 and 4. So using this logic, you will be able to cross check your answer. Now we'll go to a CBSE paper and see how they have asked the question there. See this question. Attempt either option A or B. It's also an optional question. So here we have a parallel connection. Find out the following in the electric circuit given in the figure. First one is effective resistance of two 8-ohm resistors in the combination. So here we'll use the parallel connection equation. 1 by Rp is equal to 1 by R1 plus 1 by R2. So here 1 by Rp is equal to 1 by 8 plus 1 by 8. 1 by Rp is equal to 2 by 8. When we take the reciprocal, Rp is equal to 8 by 2, that is 4 ohm. This is the answer. Okay. So we already know that in parallel connection, when you have two same resistors, the effective resistance will be half of it. But still, steps are needed for us. That's why we should do the steps. Now, second one is current flowing through the 4 ohm resistor. We know this is parallel connection. In parallel connection, the potential difference is same, but current is different. That's why they're asking us to find out the current across the 4 ohm resistor. This question might confuse us slightly because here we have two types of combinations. Here in this area, this is parallel connection, but this one is connected in series. So in series connection, the opposite happens. The current will be same and voltage or the potential difference will be different. So here current is same in the sense whatever current is there in the circuit, that complete current will be coming here as well. So even though they are asking you the current across 4 ohm resistor, they are indirectly asking you the total current in the circuit, how much current will be there in the circuit. So if you take all the total values, you will be able to get the current. So first of all, let's see what is the potential difference here. V total, that is given as 8 volt. Since we are taking all the total values, we should take the total value of resistance also. So R total is equal to, already we got the resistance here is 4 ohm, here also it's 4 ohm, both are connected in series. So our total resistance will be 4 plus 4, that is equal to 8 ohm. Okay, we have that also. Now it's easy for us to find out the current. I total is equal to what? We know I is equal to V by R from Ohm's law, that is V is equal to IR. That is equal to V. V is 8 and R is again 8. 8 by 8, that is 1 ampere. So our current here is 1 ampere. This is the answer. Let's see the OR question also given by them. So here in the OR question, it's a similar question. Study the circuit and find out the current in 12 ohm resistor. So how much current will be here? Again, this resistor is connected in series with it. So indirectly they are asking us the total current here. So again, as we did earlier, it's 24 and 24. So when we use the equation 1 by Rp is equal to 1 by R1 plus 1 by R2, since both the resistors are of same value, we'll get half value of it. So Rp, R parallel will be 12 ohm. Okay, so 24 and 24, half of 24 is 12 ohm. So if you use the equation 1 by Rp is equal to 1 by R1 plus 1 by R2, finally we'll get this answer. We are able to say it earlier because if in parallel connection, if we have same resistors in parallel connection, then the effective resistance will be half of it. That's why. So here we have 12 ohm. Again, here also we have 12 ohm. So the total resistance, R total will be equal to 12 plus 12, that is 24 ohm. Again, the total voltage or the total potential difference is given as 6 volt. Now we have to find out the total current I. I total is equal to what? We know I is equal to V by R, that is equal to 6 by 24, that is equal to 6 one time, 6 4 times. So I is equal to 1 by 4, that is equal to 0.25 ampere. So the answer is 0.25 ampere. Now in the second question they are asking us the difference in the readings of ammeter A1 and ammeter A2. This is also to test whether we know the concept about parallel and series connection. We already told that in parallel connection, potential difference or the voltage is same and current is different. In series connection, current is same but potential difference is different. So here, looking at this figure, in between this 24 and 24, it is a parallel connection. So potential difference will be same, current will be different. But when we compare this part with this single resistance over here, this is a series connection. So here and here, or if you just look at the ammeters, this ammeter is connected in series with the circuit with this ammeter. Ammeters will be always connected in series. Ammeters are always connected in series. So when they are connected in series, automatically the current across both will be equal. So difference in the readings of ammeter, there won't be any difference. Both the ammeters will show us 0.25 ampere, and here also it will show 0.25 ampere. So there is no difference, or we can say the difference is 0 ampere. There is no difference. That's it. I hope you understood question number 34 clearly. So question number 34 will surely come from electricity chapter, where an OR question also will be there. A similar OR question also will be there. So practice the questions like this, prepare well. We'll continue with the next question in the next class. Thank you.